Hello, everyone, and welcome to the May 20th Professional VMware.com vBrownBag. Tonight, we are continuing our VCP6 Foundation series, and we're going to be covering Section 3, which is shared storage with Mr. Hersey Cartwright. Hersey, how's it going?
Not too bad.
Ready for lots of live demos and such tonight?
I hope so.
Awesome.
So far, everything's worked up till now.
Excellent. Well, I'll give a drink up to the live demo gods for you. A few show notes before we get started. As always, you can hop into the conversation on Twitter with the vBrownBag hashtag. If you've got any questions, you can pop them up there. I'll keep an eye out for them and ask them. You can also post questions in the GoToWebinar chat, and we'll get those to Hersey. Or you could also raise your hand for your question, and we can get you on live as well. You can catch all of our current series at professionalvmware.com/brownbags. We've got the Google Cloud Platform series, which is going to be a Tuesday evening series starting next week on the 26th. You can register for that. It's a separate registration, so if you're already registered for this particular show or one of our other shows like our APAC, EMEA, or Latin America show, this is a different link you'll get. You can go to bit.ly.com/v and then BBGPC all uppercase. Again, those other shows you can catch Tuesdays, us normally on Wednesdays, and our Thursday shows, APAC in the morning US time, nighttime for those folks, obviously, and later on Thursday for our Latin America show. Podcast, if you want to download them, we've been doing a much better job. Thank you, Alistair, for getting those up on iTunes, bit.ly.com/brownbag iTunes, or your favorite Android or generic RSS feed at bit.ly/brownbag podcast. Follow Hersey on Twitter at HerseyC, and I'm your host for tonight at JFrappier. So if you've got any questions, again, pop them on Twitter and include that vBrownBag hashtag so we all see them. And with that, I am ready to make you presenter, sir.
Okay, ready to go.
Got to remember how to do it.
Ha.
There we go.
So did it share the right screen? Can you see the?
Yeah. I've got your presentation after. I'm pretty sure I didn't share my screen, so I did all that
Okay.
and didn't have any of that up, so I'll add that in after the fact. Hooray, edits.
Okay. Yeah. So just a little bit about me, Hersey Cartwright. I am a VCDX number 128. So defended at PEX a year ago. I'm also a V expert since 2012. My website, vhersey.com, and Twitter, like Jonathan said, at HerseyC. I also wrote a book. It was released in 2013 or just in 2014. So I wanted to plug that a little bit. Still, I know it's vSphere 5, but it's still fairly relevant. It is a design book, so most of the concepts are still relevant, whether it's vSphere 4, 5, 6, really doesn't matter. Just wanted to point out a couple of community resources and study guides. If you're looking at the VCP6, everything right now is still in that beta exam stage, including the foundation exam and the VCP exam. And I don't know if they have a VCA exam, whether that's in beta or whether that's full bore or not. But I have a study guide that's still kind of in progress. It's about half done. There's a few other ones that are really good. And then, of course, the vBrownBags, this series. Also, we are talking vSphere 6 here, but a lot of things are still relevant with vSphere 5 and 5.5. So if you're kind of new to it, definitely worth brushing up on some of that. So tonight is Section 3, which is configuring vSphere storage. The Section 3 is broken into 3 different objectives, and then each of those objectives are broken out into a bunch of tasks. And we should be able to get through pretty much all of the tasks of all of the objectives. The presentation doesn't necessarily flow with the blueprint, but everything is pretty much there. The link to the blueprints in the slide deck, and I'll have the slide deck posted on vhersey.com, and I'll also provide it to professionalvmware.com so they can post it when they post the show notes. So just some of the stuff we're going to be going through tonight. It is the foundation exam, so most of the tasks are I don't want to say simple, but most of them are basic tasks that you would do when standing up a vSphere environment. It does get a little bit into the vSAN, and then the storage DRS clustering is also part of the objectives. So that's kind of a little bit more of the advanced, but the stuff like just expanding VMFS data stores, creating a data store, NFS, multipathing, and we're going to go through some lab and demos of all of that. So I just kind of wanted to start with, what's new as far as vSphere 6 storage goes. I mean, so if you're prepping to take the foundation exam and you're already either a vSphere 5.5 admin or a vSphere 5 admin, or you have some familiarity with 5, but not a whole lot with 6. This will just give you an idea of what you can kind of focus on as far as what's new or what is significantly different. NFS version 4.1, which we're going to talk about a little bit later, but I just kind of wanted to bring all of this stuff out. Virtual volumes, vMotion support for physical RDMs, which is a pretty cool feature. If you're doing any kind of Microsoft clustering services with physical RDMs, and in the past, vMotion wasn't supported with that. With vSphere 6 it is now. vSAN 6.0, which includes the fault domains and then the all-flash vSAN. And then VMFS 3 is completely depreciated. So if you only stand up a 6.0 environment, when you provision a VMFS data store, doesn't matter whether you use the legacy vSphere client or the web client, where it used to ask you, do you want to format this VMFS 3 or VMFS 5, it doesn't even ask you whether you want to use VMFS 3 or not. You still can present VMFS 3 data stores so that they can be upgraded to VMFS 5, but you're not able to actually provision VMFS 3 data stores anymore. So now just to kind of get into the objectives, so one of the first objectives, one of the first tasks is just identifying storage adapters and devices. And that's understanding the types of storage devices that are available to vSphere 6 host. So SCSI, that's local direct attached disk, iSCSI, hardware and software, fiber channel over Ethernet, and there's also a hardware and software initiator for fiber channel over Ethernet, and then Ethernet, which is just NFS or NAS, and then the software defined stuff, vSAN and virtual volumes. So another task is just identifying the naming conventions, and there's several of them for every device and every data store. They have the SCSI inquiry device identifiers, which are unique and persistent across reboots, and these are the EUI, the T10, the T10 or the NAA device names. Then there's the path-based identifiers, and these are not unique and not necessarily persistent across reboots. And these are VMHBA, and then the HBA number, the channel number, the target, and then the LUN number. Then there's a legacy identifier, and this legacy identifier is the only one, I believe is the only one that you cannot see in the web client. You actually have to go to the ESX CLI to be able to see this legacy identifier. But it's generated by an ESXi host, it's unique, and it's persistent across reboots. It takes some information from the target or the device, and then generates a unique identifier for that device. Then there's a device display name, which can be modified. Then there's a couple other naming conventions that are specific to storage protocols, and that's for Fiber Channel, the worldwide node name and the worldwide port name, and then for iSCSI, the IQN. Understanding these naming conventions and understanding what the different pieces of them mean is definitely a testable piece there. So being able to identify, which channel or which target, if you're given this path identifier, is something that you should probably know. Same thing for the iSCSI, the IQN. So the IQN, that name is made up of the year and the month of that the company's domain name was registered, the top level domain name, so and then the domain name, and then a unique ID for the host or the target. So for VMware, for the software iSCSI, I believe this is like 2001-01.com.vmware, and then a colon and the host name followed by a hex, uniquely generated hex number. And like I said, most of this you can see in the web client.
And remember, everyone, the web client's the only way.
Yeah. Yeah, until you get tired of using the web client. Yeah, so if you go to the host and you go to storage and storage devices for that host, you can see the identifier, which is that NAA name. This name here is the device name, which is configurable. So you can actually rename this device. I don't remember which one that was, but we'll just say it's one. And then it may not refresh right away because it is the web client. But that gives you the the path info, all of that identifier information. And like I said, you can see everything here except for the legacy path name or that VML name. For the paths, that's where you'll see that runtime name with the host bus adapter, the channel, the target, and the LUN. So another piece of the first section or the first objective is just kind of understanding what zoning and masking is. So zoning is a fiber channel function. It's to control and isolate paths in the storage fabric. You define which ports can connect to which targets. So which ports on your HBA, on your ESXi host, can connect to which target ports on your array. Single initiator, single target is the preferred zoning method for ESXi. So it's not the only method you can use. That's kind of the supported best practice method is single initiator, single target. There's a link in here. Again, the presentation will be posted. But just for kind of a good overview for people that aren't real familiar with fiber channel, just kind of what zoning is, the difference between soft zoning and hard zoning, and the different single initiator, single target, multi-initiator, multi-target, the different ways you can do zoning.
What
so then
is
masking?
We had a question in chat, or a request if you could describe the difference between hard and soft zoning.
So yeah, I probably could. It kind of goes outside the scope of the foundation exam, right? And that's why I kind of included those links. But soft zoning is where you use the node names, okay, and then any port that's connected to that WWN name can be zoned into the other, to whatever worldwide node name that you've zoned in. So you just use the node name of the host and the node name of the array, and it doesn't matter what ports, what the WWPNs are, they'll be zoned in together. Hard zoning is when you do it by port names.
Cool, thanks.
Does that answer the question?
Yeah, I think so.
Okay, cool. But this is a really good article, even if it is a bit dated. Fiber channel hasn't changed a whole lot other than the speeds. The concepts are basically the same. So this is a really good article that goes through the zoning practices. Pretty short to the point, but good information. Then masking, that's a process that makes a LAN unavailable to some hosts while still letting it be available to other hosts. This can be done either on the host using the mask path module of the native multipathing architecture, or you can do it on the array by just not allowing some host to access a specific LAN on the array. Probably the biggest use case for this is boot from SAN, where the boot LAN for a host has to be masked from all other hosts that have access to the array. So the boot LAN in a boot from SAN scenario can only be presented to a single host. So hardware and software iSCSI initiator requirements. So hardware iSCSI, that's a HBA that's capable of offloading iSCSI and networking processing. So the HBA handles all of the iSCSI encapsulation and networking. These can be dependent or independent. So a dependent hardware iSCSI uses a VM kernel interface, or an independent iSCSI with hardware iSCSI which doesn't require a VM kernel interface. With the independent, the networking and everything is all handled on the HBA. So you configure those, the network addressing and stuff on the HBA itself, not in vSphere. Just a thing with hardware iSCSI, bidirectional CHAP's not supported on independent adapters. Bidirectional CHAP is supported on dependent and the software-based iSCSI initiator. The software iSCSI, that's just a software-based initiator, so it's an initiator that's part of the ESXi image. It requires a VM kernel interface, but it doesn't require any specific hardware other than a network adapter. One thing to note, if you are doing multipathing, so you have multiple paths to an iSCSI target, you can't mix that pathing across hardware and software adapters. You can mix it, it's not supported if you do it that way. And I'm just going to go through a quick setting up, the multipathing for iSCSI. So it does require a VM kernel, which I've already configured. I have 2 VM kernels configured for iSCSI A and iSCSI B. They're both on the same subnet, both on the same vSwitch. One of the things you have to do when they're both on the same subnet is bind those VM kernels to the software iSCSI. I've already enabled the software iSCSI adapter. If it wasn't enabled, this little plus sign here would be green. You just click on that and click enable the software iSCSI adapter. If you have an FCOE capable NIC in there, it will also give you the opportunity to then also enable a software FCOE adapter. So you have to bind the iSCSI VM kernels to the software iSCSI adapter if they're both on the same vSwitch and they're both on the same subnet for multipathing to work correctly. I've already bound iSCSI A, but you'll see iSCSI B is not recognized, and that is because it has to be compliant to be used as an iSCSI, a software iSCSI VM kernel before it can be bound. To be compliant, is it here? No, I got to do it here. Still remembering where things are on the web client. To be compliant, the VM kernel that's going to be used can only be associated with a single NIC. And by that means a single active NIC, so they can't even have other NICs in standby. So what I'm going to do is I'm going to override the failover order, set VMNIC2 as my active adapter for that VM kernel, hit OK. And now if I go back to storage and network binding, that will show up as a valid port or VM kernel that I can bind to this adapter. So anytime you make any changes to your iSCSI configuration or storage configuration, you will probably need to rescan your storage. So I'm just going to run the storage rescan. And is what should happen is now I should see multiple paths to the target. And in previous, I only had a single path. Now I have multiple paths to each device. There's a place that's easier to look at that, but it's escaping me right now of how many paths are available. No, it's not there.
When in doubt, related objects tab?
It might be. No, it's not here. No. Yeah, I thought it was under storage devices, and it just may be that it's not that the column's not shown. There it is. So I have the two targets, 3 different devices, and then 6 paths. So there's 2 paths to each device now since I added that second path, that second VM kernel to be used as a path on that. So yeah, there it is. Get a little bit now into VMFS, or the virtual machine file system. So VMFS 3 has been depreciated in vSphere 6. VMFS 5 has been the same since vSphere 5. It uses the standard 1 meg file system block size. If a VMFS 3 data store is upgraded to VMFS 5, it'll maintain the legacy block size. So if in previous versions, when you provision the VMFS 3 data store, you could select a block size, and that you determine that based on the size of the VMDKs that you were going to store on that data store. So if you had configured that block size to, let's say, be an 8 meg block size, if you upgrade a VMFS data store from VMFS 3 to VMFS 5, it'll maintain that block size. The only way to change that block size is to reformat the data store. So delete the data store, delete the VMFS file system off of it, and then reformat it. VMFS 5 supports storage devices and virtual machine disks greater than 2 terabytes. So up to a 64 terabyte device and a 62 terabyte virtual disk. It uses the GPT partition table. New data stores that are created with VMFS 5 are created with the GPT format. If you're upgrading a data store from VMFS 3 to VMFS 5, it'll maintain the MBR partition table until the data store is expanded beyond 2 terabytes. Once it's expanded to beyond 2 terabytes, it'll convert the MBR to GPT. The upgrade is online, so you don't have to move VMs off of it, or there's no data loss or impact to the data going from VMFS 3 to VMFS 5. You can also expand or extend a VMFS 5 data store while it's online. And then 256 VMFS data stores supported per host. So just to kind of go into adding a data store or expanding a data store, we'll start there. We'll expand this data store. It's pretty easy. Just increase data store capacity. So this data store was originally a 30 gig data store. On the array, I expanded that data store to be 40 gig. So now I need to expand the VMFS file system to consume that whole 40 gig of space. If you're expanding on the same device, then it'll show that it's expandable. So I'm just going to select that because I'm expanding into the same device. Next. Then we are going to expand to that free space that it was available on the device. And then it'll now tell you that, all right, so we're increasing the data store size by 10 gig. So when this is done, this data store formatted will be 39.75 gig. We let that run, give it a second. And now the capacity is 39.75 gig. Adding a VMFS data store is just creating a new data store. We're going to create a VMFS data store. I'm going to use this LUN1, which we renamed earlier. I'm going to use the full, everything that's available as VMFS. So there will be a 30 gig data store once that completes. You can rename a data store. And you can do this while it's got VMs on it. Won't impact anything, but you can rename the data store. The other thing that you can do as far as increasing data store capacity is you can add an extent, which is taking another LUN and expanding that data store into that LUN or volume. So this is not really the recommended way to do it. I mean, you should expand a data store and then grow into it with the VMFS. But if your array doesn't support that, or if you have a legacy array where you can't expand your data stores, or for whatever reason, that this is another method to kind of increase the data store size. So we're just going to select to use this as an extent. We're going to use all available partitions. So now we're going to increase this data store size by 10, and it'll then be 39.75 gig data store, just like the other one. One of the differences here is when you look at it, you will see both of those devices as part of the data store, whereas this one is only that single device. So then the next thing, network file system, or NFS. iSCSI has now includes 2 NFS clients, one for NFS version 3 and one for NFS version 4.1. You should only use one NFS version to access a data store. So on the NFS server, the share should not be exported as both an NFS version 3 and an NFS version 4.1 data store. Only use one NFS version for data store. There is no upgrade from NFS version 3 to NFS version 4.1. It'd be a migration, so you would present a new share, export it as a NFS version 4.1 data store, mount it as an NFS version 4.1 data store, and then migrate things off of the NFS version 3 data store onto the NFS 4.1 data store. NFS data stores can be mounted read-only, so you can use them for like an ISO repository or a file repository where you don't want people writing to it, or you don't want to store virtual machines on it that can run. It can be mounted read-only. Support for vMotion, HA, DRS, and FT. FT is not supported on NFS version 4.1, and neither is storage DRS. By default, when you provision VMs to a NFS data store, they're provisioned thin, unless hardware acceleration supporting reserved space operation is used, and usually that's a VIB that gets installed on the ESXi host for the array to enable the hardware acceleration for NFS. NFS version 4.1 does not support that hardware acceleration. So the new bits with NFS version 4.1, it supports NFS multipathing, so you can have multiple paths to an NFS data store. Supports non-root user access when using Kerberos authentication, so you don't have to do the no squash root on the export for NFS version 4.1, but it does not support VMware fault tolerance, storage DRS, storage IO control, SRM, or VVOLS. So it can't be used as a protocol endpoint for virtual volumes, and it doesn't support NFS hardware acceleration. Again, the share should be exported as either version 3 or version 4.1. Don't provide both protocol versions to the same share, or you may have data corruption with things you're storing on that share. Chris Wall, wallnetwork.com, he did a fantastic write-up on vSphere 6 NFS version 4.1, so that link's here, a great reference point for that. So we'll go back in here and we'll just mount an NFS data store. Do it the same way, just a new data store. And the type, we're going to choose NFS. And I have to remember what my IP address of my NFS server is. I only have, my array is only capable of NFS 3, so I'm only going to be doing an NFS 3 data store. We'll give it a name, NFS data store 3. You give it the mount point for the share. And then the IP address or the DNS name of the NFS server. And then if you wanted this to be read-only, you'd select mount NFS as read-only here, and then it would mount it as a read-only. So this is one of the things that's kind of cool that you couldn't do in the thick client, and that was mount the NFS share to multiple hosts in the one wizard. So with the thick client, you had to, if you were going to mount an NFS share, you had to go through and mount it to each host. In the web client, you can select which host you want it to mount to. If you wanted to mount it to all of them, you could do that. This is the only host that's set up for access to that share. So and if everything works right, I should have another NFS data store there momentarily. Yep, and there it is. So that's the new NFS data store. Now it's ready to be used as a data store to provision VMs to templates, ISOs, what have you. So storage DRS. So storage DRS uses data store clusters or clusters of similar or interchangeable data stores. So basically, it doesn't have to be, but really it should be. The data store should be similar in performance and capacity characteristics. It works similar to vSphere DRS, where you create this storage DRS data store cluster. Then you enable storage DRS on it, and then you can load balance across data stores within the cluster for either performance or capacity, or both. Just like vSphere DRS does the initial placement of a virtual machine when you power it on, storage DRS does the same thing when you're the initial placement of a virtual disk, and it bases it on space and I/O balance across the data stores within the data store cluster. Migration of virtual disk from one data store to another, again, based on either capacity or space available and I/O workloads to kind of balance the workloads across multiple data stores. And then data store maintenance mode, which is very similar to host maintenance mode in vSphere DRS, where you can place a data store in maintenance mode and it will evacuate all of the virtual disks that are on that data store onto another data store within the cluster. Data store clusters are, again, very easy to set up. So this one, no, wrong cluster. Well, I said it was very easy to set up, and now I can't find it. There it is. New data store cluster. We'll just call this iSCSI data stores. I'm going to go ahead and turn on storage DRS. It lets me set some options here, just like you would do in vSphere DRS. I'm going to go ahead and set this to fully automated. If you wanted to do it on I/O, based on I/O, you have to turn on the I/O metric for DRS recommendations, so that way it tracks what's going on from a workload or I/O. What I/O is happening on the data stores that are in the cluster. If you don't enable that metric tracking, then it won't do storage DRS recommendations or migrations based on I/O. The space threshold, so how much space do you want to consume on a data store before it decides to, okay, I'm going to balance things based on capacity. So until I hit this, it's not going to move anything to another data store. And then the I/O latency threshold, so at what threshold is it going to do before is it going to meet before it considers moving things to another data store within the cluster. I'm just going to select my lab cluster, and then I'm going to put my two iSCSI data stores in there. So what that'll do is that'll create this new iSCSI data store cluster that has those two iSCSI data stores in it. Now when you provision a VM now, I'm just going to go through the defaults. When you select the storage, now you'll select that cluster instead of selecting the data store. So it can place it on any of the data stores within that cluster based on its recommendations for capacity and performance. Let me just go ahead and provision it. So now if we look at that hard disk, we can see that it's on that data store LUN, that it was placed on LUN 01, which is part of that data store cluster. So now if we were to go back into here and then go back to the data store cluster, which one was it on, that one? And we can put this in maintenance mode, which is somewhere here. So we're putting that data store in maintenance mode, and what it will do is it will migrate everything off of that LUN and place it on to another LUN or another data store in that cluster. So I don't remember whether this was part of the foundation exam or whether it's part of the VCP6 DCV exam, but one of the things was just kind of going over use cases for why you would do multiple VMFS or NFS data stores. So one is performance, so provision based on performance characteristics. So if a data store is backed with RAID 10 or RAID 5, there's going to be different performance characteristics from a write penalty standpoint, or whether the data store is backed by SSD disk or cache. Then data protection features. So is the volume that the data store is provisioned on, is it replicated? Are snapshots taken of it? Recovery and fault domains. So the number of VMs that would be affected by data store failures. That has a lot to do with how large you would make your data stores. So not just VM capacity on a per VM basis. So you may need a large data store because you have VMs with large disk, but also how long would it take you to recover a data store based on the size or based on the number of VMs that are on that data store if you were to have a data store failure. Another thing is availability, separation of VMs or VM disks to reduce the impact of a failure. So if your virtual domain controllers, if all you've got is virtual domain controllers, you don't want them both potentially provisioned on the same data store, and you have a corruption or user error that deletes that data store or what have you, and you lose all your domain controllers. So just separation. And then load balancing load and or capacity just across multiple data stores. So then virtual SAN, so 3 hosts providing storage or disk groups is required. You can do it with less, but there's some stuff you have to do. Supported 3 hosts providing disk groups. Each disk group has to have at least one SSD and one spinning disk or hard drive per disk group. A SAS or SATA HBA or RAID controller that's on the HCL and it's configured in pass-through or RAID 0 mode. So there's some network requirements, dedicated 1 gig for hybrid configurations, but 10 gig is recommended. Dedicated or shared 10 gig for all flash configuration. So you can use a converged network adapter, multiple 10 gig adapters that you're sharing with other storage or other traffic types. But it does require 10 gig for the all flash configuration. VM kernel adapter configured for virtual SAN traffic type. Multicast must be enabled and supported and enabled on the physical switches and routers. And IP version 6 is not supported for vSAN traffic. So vSAN, I did a blog post on vhersey.com about this. It's fairly simple to lab up, even if you don't have SSDs. So I have this nested lab environment with 3 ESX hosts. Each ESX host has a 10 gig disk where I'm loading ESXi on. So this is just the local disk that has the hypervisor. Then a VMDK that is 100 gig, and then a VMDK that's 10 gig. Now, those VMDKs, they show up just as hard drives. And in vSphere 5, or 5.5 even, I think, to be able to, you could tag that any disk as an SSD, but you had to go to command line to do it. They added it to the GUI where I can just call this disk a flash disk, even though it's not really a flash disk. Once that takes effect. So now each of these hosts, they're configured just like this. They have that 10 gig disk is a flash disk, and a 100 gig disk that's going to be just a regular hard drive. Each of the hosts are configured like that. And then on the networking side, There's a VM kernel adapter. That's been tagged for virtual SAN traffic. So enable in vSAN, probably seen this in a webinar or in some marketing media. It is just as simple as clicking a button to say turn it on once you have the configuration back in place. You can select adding the disk mode from automatic to manual. Manual means basically you control how the disks are going to be added to disk group. Manual, just any empty disk on the host are automatically claimed by the vSAN. I'm going to turn this to manual. Hit OK. So now vSAN is turned on. Is what that's going to do. Here's what it should do, is create this vSAN data store that is empty. So it has no capacity. That's because there's no disk backing it yet. So we'll go back to the cluster settings, go to disk management, and then I can claim disk on each host. It's going to create a disk group on each host that's going to include that one 10 gig flash or the 10 gig disk that's been tagged as flash, and then that 100 gig unused local disk. And well, that sucks.
Can you just hit enter?
Yep, that's what I did. We'll see if it actually took it. I don't think it did. Oh, maybe it did. No, it's not showing anything yet. Oh, yep, there it is. It did take it. So now there's a disk group on each host, and if you look at that vSAN data store now, you'll see that it's showing those the capacity of those three 100 gig drives. You know, the vSAN, kind of the way it works, you know, each of these disk groups is independent, right? So there's no kind of like parity or RAID across those groups. When you provision a VM to the vSAN data store, you apply a policy to it. So you can say that you want this specific VM to be able to survive a single host failure. So what that's going to do is that's going to basically create a copy of that VM on two of the disk groups, on two separate hosts. So if a single host fails, or a single vSAN or even disk group or host fails, then it's still available on another disk group. Fault domains, can't do a fault domain, but that's a newer feature of vSAN 6. By default, each host is its own fault domain. If you had multiple hosts, let's say across multiple racks, and you wanted N+1 across racks, then what you could do is place host in those fault domains that are in those racks. So then if a rack fails, you have another copy of the VM on host or disk groups that are on host within another rack. You have to have at least 3 fault domains because of the way vSAN works with that disk groups across multiple hosts. Virtual volumes, and unfortunately I don't have a way I can do this in the lab because I don't have any storage that supports the VASA providers. It requires vCenter, so vVOLS can't be used on standalone host. There's a VASA provider that gets enabled on the array, Then a storage container is created, which is a pool of capacity or aggregation of storage capabilities. So it's a pool of disk and then the capabilities associated with those disks. On the host, there's a protocol endpoint, and that's how the host communicates with the vVOLS. That's basically your data path. Those protocol endpoints, the same connectivity that's supported with other storage connectivity, FCOE, FC, iSCSI, NFS protocols can be used for protocol endpoints. IPv6, even though it may be supported for some of those other storage protocols, it's not supported if you're using vVOLS. And then NFS version 4.1 is currently not supported. A virtual data store is created, so it looks just like a regular data store when you're managing it. So it would look just like this. It's just the backing is different. And this data store to the storage container on the array is a one-to-one association. There's actually a couple of pretty recent vBrownBags that were done on virtual volumes that are really good and go, way deep into it, way deeper than what the foundation exam is going to require you to go into it. And that's really all I had as far as the presentation and the lab demos. So in the deck, all of the links to the different resources that are in the blueprint are there. The blueprint, they're doing the blueprints a little different. I don't know if this is just for the beta or if this is how they're going to go. And I say they, VMware certification is going to be doing it in the future. But the blueprints are HTML. They're not a PDF like we used to download a PDF for the blueprint for previous exams. Now it's just HTML. But these are the tasks and objectives we went over tonight through this. We've got a couple minutes left, so I'm open to any questions or if there's anything anybody else would like to see.
So we've got one question in chat that I was answering, and I'll defer to you. The question was around vSAN and are there benefits to having more hosts in a vSAN cluster or any place where you run into limits?
So the vSAN limit is the same limit as the cluster size. So 64 hosts now in a cluster, I think.
Yep.
And that's the vSAN limit, right? So a couple of things you got to think about with vSANs is not just your host, but also sizing your disk groups, okay? Because remember the way vSANs work, it's all policy-based, and if you've got like an N+1 policy, so I want to support one host failure. If you have VMs on a host and then their stuff is also stored, replicated somewhere else within that vSAN cluster, if that host fails, then it has to replicate that VM to another host or disk group on another host to be able to maintain compliance with the policy, with the N+1 policy. So what you have to be careful of is, okay, so if you have these really large disk groups, right, and you have a failure where you lose that disk group, then that whole disk group has to be, or everything that was on that disk group has to be created somewhere else. As far as limits, I don't know what like the storage limit is on vSAN. What's the maximum size it could be?
Yeah, I'd have to go read the config maximum guides, which I should probably consider doing since I'm taking the Delta on Friday.
Well, so since the vSphere 5.1 exam, luckily we haven't had to really worry about config maximums specifically. There's none like what's the maximum amount of RAM you can give a VM. That was part of the earlier VCP exams. Luckily that hasn't been part of the blueprints for the since like the 510 exam. I took the Delta exam 3 weeks ago. It was really good. A lot harder than I expected it to be.
Yeah. More, you think they're pushing the exam limit some since we're chatting
I,
here?
I think they might be. I think the other thing is so one thing I kind of thought about the exam is they ask you as much about why you wouldn't do something as why you would, or why something couldn't be done as much as why it could be done. So I don't want to get too NDA or too deep into that, but to say, instead of just saying you need X, X, and X to do this, okay, it would say you have X, X, and X. Can you do this? Does that make
It's really
sense?
more making sure that you've understood a topic versus memorized some
Right,
specific bits out of a guide. So really sounds like more making sure you've grasped the concepts properly as a whole and understand how they're applied versus just knowing that you can have 64 hosts in a cluster.
right. Good exam, tough. I didn't put a whole lot of time into studying for it. That's probably going to be reflecting my score for sure. I don't really know how. I don't have a feeling of really how I did. I don't think I did that well on it. But it was a good exam.
Excellent. I'm looking forward to it myself. I've been reading all the various vSphere 6 PDFs that they've got listed in the blueprints online for Foundation and the Delta exam. So there's a lot of links in there too. That website you showed, and I tweeted it out for folks that are on Twitter. You can go find it, and it's actually posted, I think, on our sign up page for the vSphere 6 series, so you can find it there as well. And that looks like all the questions we've got for tonight, sir. So thank you very much. I am going to share my screen now so that I could more easily show my yes, show this because I'm going to have to edit this in later since I forgot to do it earlier. Hersey, thank you very much for the demo tonight. Keep an eye out on our website and on iTunes for the follow-up post. We'll post this probably within about a week or so. A little bit behind, but getting caught up post EMC World. So thanks everyone for listening, and thank you, Hersey.
I appreciate it.